Hello students, I am Vishwajeet Poddar and I am before you with chemistry lessons. But before I start any to know, how's your NEET preparation going on? How do you feel about NEET preparation? How comfortable are you with this subject, especially chemistry? Anybody to say anything? Anyway, think over it. How are you feeling about chemistry particular lecture? We have with us Riya Tyagi, Baijanti Das, Sakshi Chauhan. We have a lot of students. You are all welcome. Okay. Yeah. If it has to be rated, preparation, regarding your preparation, 1, 2, 3, where do you rate? 1, 2, or 3? Right? This is my brief introduction about myself. I'm associated with chemistry teaching for past 15 years and I've trained more than several thousand students. I was associated with a couple of well-known organizations of Delhi. That was with them in their classes, Akash Institute. And then I am here with Altedemy and teaching chemistry. And today's topic that we have taken up, the topic is one of the topics of inorganic chemistry that we call this as hydrogen. Hydrogen lesson 1. We have divided entire chapter of hydrogen into 3 different parts. Hydrogen lesson 1, hydrogen lesson 2, hydrogen lesson 3. In lesson 1, we will be talking about hydrogen. Hydrogen, when we a couple of things that so when we are talking about hydrogen atom. These are a few things that you should bear in mind. These things are what, when we are saying hydrogen, hydrogen means these are the things that we have mentioned here. We mean hydrogen atom. We can also understand hydrogen molecule. We can have hydrogen ion as well as hydride ion. These are the things that you can understand. We have various kinds of hydrogen that we should bear in mind. Like,
one second, sir.
yeah, once again, we had a small break there. So we are just coming once again. In this first part of hydrogen, we should bear in mind that we have the syllabus that is now being shown onto your screen. You have to study about position of hydrogen in the periodic table. You have to talk about occurrence of hydrogen, isotopes of hydrogen, lab preparation of hydrogen, commercial production of hydrogen, physical properties, chemical properties, uses of hydrogen, and these are some of the things that you have to bear in mind. Just to make your presence felt here in the class, I have given photographs of a couple of these gentlemen. I don't know whether you are aware of their background or you are aware of these gentlemen or not, because they are associated with hydrogen discovery as well as doing research work on hydrogen. Very famous Lavoisier, you must have heard the name. And another person is Henry Cavendish. Briefly, I'll tell you about Lavoisier as well as about Cavendish. Lavoisier was a French person, and he was originally a biologist and a chemist both. And whatever happened with Lavoisier, despite having in his uh, belt scores of discoveries that includes hydrogen also, Lavoisier was executed in France. It's a very typical kind of a story. Whatever worst that can happen with a scientist or an intellectual person, that can happen with Lavoisier. Lavoisier was executed in France. And the day when Lavoisier was executed in France, the French press, they wrote that France no more needs scientists. You will read about Lavoisier when you will take interest into it. But you should know Lavoisier was one person who was associated with the discovery and other reaction patterns of Lavoisier. One of the things that you must have heard must have read in your basic concepts in chemistry, that one of the uh, you know kind of very basic things Lavoisier gave. Can you name that? What was that Lavoisier gave? Anything that you recall from your chapter 1 basic concepts in chemistry, what Lavoisier said? Which kind of theory Lavoisier gave? Law of conservation of mass, law of definite proportion, law of multiple proportion. If you remember, you will find there are a couple of discoveries that Lavoisier has done. Anyway, the second person whose name is originally associated with Cavendish. Cavendish was a person who is originally given the credit for discovering hydrogen. About Cavendish, Cavendish was an English person. About Cavendish, it is said that he was the richest of all the learned person of England. And he was learned of all the richest person in England. He was a very shy person, very shy. Even the day when he died, he died normally. His death was not like Lavoisier. He died, he gave proper salary as well as the leave to his employees and attendants in his house, and he generally had a backdoor entry in his own house. He generally did not prefer that I should enter into my house from the front door. He was shy to that extent. He did not marry, and when he died, he had plenty of money, and obviously it gave to English government, and this is how Cavendish was associated. Very interesting people, and in fact, in history, if you go into the history of science, you'll find many such interesting people. But the only thing is that you need to know, and I have a typical habit of making you aware of these scientists or these gentlemen who are associated with this particular topic. So anyway, the chapter with which we are associated right now, credit goes to Cavendish and Lavoisier. About James Deber and Thénard, I'll be telling in my second or third lectures, but here that will be good enough for right now. Let us move to our next slide. I told you, whenever we are saying hydrogen, whether it is H or it is H2, you will have to understand by the manner in which things are being put before you. And apart from H and H2, you should also bear in mind there is H plus and H minus. H plus is a hydrogen ion and H minus is hydride ion. These are four things that you will be coming across interchangeably. Often you will come across. I would like to make you aware of a couple of more things also. I think we missed that slide. It has been okay. Let us just talk about it. Suppose I write H plus. suppose I write H plus. This is somehow giving me a little bit trouble. Okay. Mhm. Actually, with this system, I am a little bit not very. It will take me a little time. Please bear with me. I think I am slightly nauseous. Okay. Look here. About H and H2. About H and H2. You will come across. I'll let you know about a small thing that is H plus. This is H plus. Any acid, if you take, suppose we write HCl or we write HCl here. You'll say it is an acid only because it gives H plus and Cl minus. And if I ask you to define what is an acid, you will generally say that acid is a substance which gives H plus ion, H plus. Have you heard about different theories of acids? You might have heard. We have different theories like theory of Arrhenius theory of acids. We have theories of Bronsted and Lorry theory of acid. We have Lewis theory. Here I'll try to mention one very small thing which is generally ignored. What Arrhenius said that HCl is an acid only in an aqueous medium. He did not mention that dry HCl will also not be an acid because it will not be in a position to provide H plus ion. Have you heard about it? Why did he say about this particular thing? That aqueous HCl is an acid, but a dry HCl is not an acid because H plus is such a small ion, such as you know about hydrogen. Hydrogen has what? Hydrogen has one electron and one proton only. It is the only element in the entire periodic table, only element in this entire periodic table which does not have any neutron. I think some of our friends have come up with this. Well, Saida is saying something, but this will be up to December 2022. I'll just clarify that matter. Good evening, everybody. Good evening, those who have joined a little bit late. I am Vishwajeet Poddar. I am continuing with your chemistry class in Altedemy. You are all welcome. This is our first chapter of inorganic chemistry, and inorganic chemistry is generally said not to be very interesting, but it all depends. How do you take it? How do you take it up? There are a lot of stories, there are a lot of industrial processes, there are a lot of very interesting things that keep on happening with inorganic chemistry. That's why you need to know. Here I am telling a very important point. H plus. When one electron is removed from hydrogen atom, it is left just with a proton. It is left just with a proton, and when it is left with a proton, you can understand this. Proton lies in a nucleus. So the size of H plus becomes very small. Size becomes very small, and there is a positive charge here. So there is a concept of VCD. It is called as volume charge density. There are two kinds of density. One is called as mass density. You are aware of density is equal to mass upon volume. This is called as mass density. Another aspect is called as charge density. You will come across this in chemistry. Frequently it will be utilized. When we'll be talking about organic chemistry, the acidic character, the basic character, and the stability of the compound or the structures, it will be decided by VCD if you understand the concept of VCD. VCD means volume charge density, charge per unit volume. A substance or an ion, if it is having charge per unit volume that is very great, that is very high. Same is the case with hydrogen ion, H plus. You can understand it has got one positive charge, and its size is very small. Size is small. That's why its volume will be very small. Size is small means the radius is small, and the volume will also be small. If volume is small, charge is one positive charge, then obviously its charge density, or so to say volume charge density, is very, very, very high. And if VCD is high, that means it is highly reactive, least stable. It will always try to get itself stabilized in whatever manner it is possible. So when we take dry HCl, it is dissociated to H plus and Cl minus, but immediately it gets attached to Cl minus. So H plus is, HCl is taken in, when it is taken in water, what happens that H plus gets combined with H2O to give H3O plus ion. Now its size become big, and when size become big, volume charge density becomes low. So it becomes stabilized. Therefore, in any acidic substance, H plus is found in combination with water, H3O plus hydronium ion. One molecule, two molecule, three molecule type of H water can get associated with H plus, and we can have things like that. Let us come to another aspect. We have in hydrogen atom, if we take H plus we talked, if we are taking H means hydrogen only, and atomic state. It is again unstable A state. What happens in this state? Hydrogen has one electron. One electron, it will always try to get paired up. That's why we have these three kinds of hydrogen here. You notice it. Nascent hydrogen, we have here. Nascent hydrogen, you can see here. We have adsorbed or occluded hydrogen. We have atomic hydrogen. There are three different kinds of hydrogen. All these three kinds of hydrogen are highly reactive. Highly reactive. The order of reactivity I have mentioned here, you can see atomic hydrogen is most reactive. Then next comes adsorbed hydrogen, and next comes nascent hydrogen. Whatever hydrogen formation takes place, commonly like we use zinc plus H2SO4 or zinc plus HCl, we get hydrogen. That hydrogen basically is a nascent hydrogen. Nascent means newly born. Newly born. Nascent hydrogen. Nascent hydrogen immediately combined with another hydrogen, and then it gets converted into H2. So we have these things. There is one very important statement that is written here. H, the character of H, ranges from Lewis base to a Lewis acid. Lewis base and Lewis acid, you should know what is the Lewis acid and what is the Lewis base. It is again an electronic concept. Lewis base is a substance which can donate a pair of electrons. Lewis acid is a substance which can accept a pair of electrons. You should not have to bear in mind that acid is the substance which donates H plus. No. We need to come over these things. We need to have three different definitions of acid bases, though we have one more definition for acid and bases, HSAB principle. I'll let you know about it, but at the moment you should know about these three: Arrhenius, Bronsted, and Lewis. So hydrogen, the property of hydrogen ranges from Lewis acid to Lewis base. It can donate one electron, it can accept also one electron. Okay. Let us come to H2, hydrogen as a molecule. Hydrogen as a molecule. In nature, naturally, hydrogen molecule is found. Hydrogen is a colorless, tasteless, odorless gas, slightly soluble in water. It is the lightest element and lightest gas. It is the lightest element and lightest gas. 1 liter hydrogen weighs 0.08987 gram at STP. 1 liter weight, this much. Very, very small quantity. And that is why small quantity you will find there is a section that we will be talking or will be discussing regarding transportation of hydrogen. Think about how hydrogen can be transported from one place to another place. If you know a little bit of mole concept, you know 22.4 liter of any gas is equal to its molecular mass. Like 22.4 liter hydrogen, if you will be taking, it will be equal to 2 gram only. 2 gram. Right? So this way we have done it. Okay. Critical temperature of hydrogen gas is minus 236.9 degrees centigrade. How many of you understand what is critical temperature? What is critical temperature and why has it been written out here? What is so special about critical temperature? Okay. Critical temperature is that temperature beyond which a gas cannot be liquefied, howsoever high the pressure may be. Look, if we want to liquefy a particular gas, there are two ways of doing it. First is by reducing its temperature. If we reduce its temperature, it can get liquefied, right? If we heat it, it gets evaporated, but gas is again in that form only. Though there is a difference between gas and vapor. Gas and vapor, we'll tell about it later. But it is already in the gaseous state. It can be liquefied. So if you will be lowering its temperature, it will be liquefied. So critical temperature. And second thing is, how can we liquefy? If we can increase the pressure, again then it can be liquefied. So by increasing the pressure and by lowering the temperature. Now, critical temperature, about critical temperature, we are saying critical temperature is that temperature beyond which a gas cannot be liquefied. You will get the notes of this class, Aswati. You will get the notes of it. Don't worry. You will get the notes of this class. There are plenty of very important information you will be getting in subsequent PPTs, and you will be getting. We are here for you only, right? Altedemy is on for you only. We have come up with right now. I mean, after a couple of minutes, we'll be talking about Altedemy, and you will be getting everything. Okay. So that's all about critical temperature. Critical temperature is the temperature beyond which a gas cannot be liquefied, howsoever high the pressure may be. Minus 236.9 degrees centigrade, you can convert it into Kelvin and can see if you will be keeping the temperature of hydrogen up to that level, I mean beyond that it cannot be liquefied. Okay. Another thing is liquid hydrogen has boiling point 20.5 degree centigrade and the freezing point is 14 Kelvin, right? Freezes in HCP but in presence of gold gives a CCP structure. About this also we'll be talking in solid state. Hydrogen is diatomic and it's Cp by Cv. What is Cp by Cv? Anybody to comment on it? Cp by Cv is known by a particular term. Anybody can tell what is Cp by Cv? It's known as Poisson's ratio. Poisson's ratio. It is 1.40. Okay. Electronegativity is very important. You should remember electronegativity of hydrogen is 2.1. And again, very important thing, the bond energy of hydrogen, HH, is 436 kilojoule per mole. It is the highest single bond dissociation energy for any element. That is why it is very difficult to break, and H2 is highly unreactive. H is reactive, H plus is very reactive. H minus is also reactive to some extent, but H2 is least reactive. Why it is least reactive? Because its bond dissociation energy is very high. In fact, the highest. For a single bond I am telling you. For single bond, it is the highest. It is strongest known single bond, it's quite unreactive. Okay, and last one statement is that bond of HH is so strong that only 0.08% is dissociated at 2000 Kelvin. And at 5000 Kelvin, 95.5% is dissociated. Can you imagine how high the temperature 5000 Kelvin is? If you want hydrogen to be dissociated, you will have to take that temperature up to 5000 Kelvin. And it is very high in temperature, right? Okay. Next we come to our another thing, H plus. I think we have discussed. We told you about this hydro H plus. We discussed a lot about this volume charge density and all those things, and it is like this. So I can just skip this slide and you can find it out. Okay. As I was telling, we'll be talking about Altedemy. Look, here we have you know you can join us on Telegram also. This is a channel for Telegram. You can join us and you can get plenty of information and the study material and other relevant things that are there for you. Like here we say that this NEET, we have given the name of the program is NEET. We give PDF material of whatever we are teaching plus whatever there are free classes. There are free classes. You will come across free classes when you will be joining this Telegram channel of us. There will be variety of announcements, there will be discounts, there will be prizes, and a lot of other things. We are doing for sake of, for promotion and for your benefit also. In our promotion, there is your benefit that is involved, and Altedemy is all committed towards it. Very sincere, very, very disciplined and very organized kind of organization, and we will try to bring about the best that is possible. We are also working very hard for your success. Okay. Position of hydrogen in the periodic table. As I told you, when we are studying inorganic chemistry, and since this is the first chapter in inorganic chemistry, you should have a little bit idea of the periodic table. Periodic table is very it is the place where all the elements have been listed, and hydrogen is also listed into this, and you might be seeing the position of hydrogen in the periodic table. Hydrogen is also called as a rogue element, R-O-G-U-E, rogue element. Why it is rogue? This is a rogue element because it has a resemblance with alkali metals as well as resemblance with halogens. There are a lot of factors of resemblance that we have mentioned here. Hydrogen has a resemblance to alkali metals which lose one electron to form unipositive ions, as well as with halogens which gain one electron to form uninegative ion. Like alkali metals, it loses one electron. All the alkali metals, lithium, sodium, potassium, rubidium, cesium, they can lose one electron. Similarly, halogens, they gain electrons. So it has a relationship with both of them, with alkali metals and with halogens also. There are a couple of more information just to let you know about this particular thing. Let me come to another slide in this situation. Okay. Before I switch over to any other slide, I would like to tell you about a couple of more things. Let us hear something more about Altedemy. And we will request you to subscribe to our channel, subscribe to our YouTube channel to get free classes regularly for Altedemy. I mean, from Altedemy. You need to subscribe. Since you are NEET aspirant, we are also into training those students who are aspiring for NEET. We come across a lot of very special and completely target oriented lectures, target oriented guidance. Moreover, we keep on conducting a couple of tests. You can participate also in those tests. I mean, the benefits are listless, but for acquiring or for taking the benefits, you need to understand that what are those benefits all about. You need to subscribe to the channel. Do subscribe. Do subscribe positively. Do subscribe positively. We are here to help you in more than one manner, but then you need to be with us so that we can guide you very properly, and with you can be benefited with our experience of training students for these NEET examination. And we are doing a lot of such things for philanthropic purposes. We are doing it and we genuinely mean it. Okay, let us come to that part. When we are saying the position of hydrogen in periodic table, first let us talk about what are the points of resemblance of hydrogen with alkali metals. These are the points about electronic configuration. You can just understand. You might be knowing about electronic configuration. You might have you might be aware that different elements, their electronic configurations are written. If we write about hydrogen, you will write it is 1s1, right? This is electronic configuration for element. Can you write molecular orbital configuration for H2? You will have to write sigma 1s2. I hope you are aware of, right? Okay. Here we are talking about resemblance with alkali metal. Any alkali metal, let us take lithium. If we are taking lithium, it has a configuration like lithium is atomic number 3, so we write 1s2 2s1, right? We write sodium. Sodium is atomic number is 11. How will you write 1s2 2s2 2p6 3s1? So you can see the resemblance, s1 s1 s1. So this is electronic configuration. It is similarity. It is electropositive in character. Electropositive. The electropositive, we all know that alkali metals are electropositive elements. Electropositive elements are those elements which generally have a tendency to lose electrons. And same is the case with hydrogen. Hydrogen in general will try to lose an electron so that it gets formed into H plus. Third thing is oxidation state. Oxidation state of hydrogen is +1, just like alkali metals. All the alkali metals have oxidation number as +1. In all there, can anybody tell me what is oxidation state or oxidation number? Anybody? Oxidation number or oxidation state? Though there is small difference between oxidation state and oxidation number, but any of the things can, if you can define oxidation number or oxidation state. Oxidation state or oxidation number is the charge possessed by an element in a compound when all other atoms are removed from it. These definitions that I am speaking, you need to follow that. These are very pinpointed definition, and often it will be serving your purpose, because in NEET normally the questions are very simple, very straightforward. Rarely you will find complicated questions in NEET. Rarely. Out of 45 questions that you are generally asked, maximum you will be having 5 questions which are complicated. Otherwise, the rest of the 40 questions are straight questions, formula-based questions, information-based questions. So, if you are studying inorganic chemistry, obviously we have started studying inorganic chemistry, the factual informations are very important for you, right? Okay. Reactions with non-metals. Hydrogen react with non-metal. Hydrogen react with chlorine to form HCl, HBr, HI. Same is the case with sodium. Sodium chloride, sodium bromide also form. In this way, it resembles, hydrogen resembles alkali metal. Oxides like Na2O, H2O is formed, Na2O is formed, H2S is formed, Na2S is formed. In this sense also, they are similar to alkali metals. They have reducing action, about which we will be talking later. Okay. Like halogens, it forms a diatomic molecules. It combines with elements to form hydride and a large number of covalent compounds. It behaves like halogens also. Halogens require just one electron in its outermost shell to complete the outermost shell. I won't say octet in all the cases. Hydrogen does not complete its octet. Hydrogen has 2 electrons in the outermost shell. Maximum it can have 2 electrons, right? But the thing is, hydrogen also needs 1 electron. Halogens also need 1 electron. Right. However, in terms of reactivity, it is very low as compared to halogens. Well, halogens are highly reactive elements. Hydrogen, it is less reactive. And rest of the sizes and other things we have already discussed. Let us come to another aspect of it. And we are talking about isotopes of hydrogen. Very important, isotopes of hydrogen. I'll tell you a very interesting fact. And if I ask, oxidation state can be changed. Okay, oxidation state can be changed. Oxidation state are definitely, it can be changed. But look here, I'll elaborate onto that point. Oxidation states can be changed. What happens with the change in oxidation state when we are saying, now let us say, suppose we have an element of group 15, right? Group 15 or group 5. I do not know, Dr. What? Need love, it's coming. It is in reference to your talk that oxidation states can be changed. Oxidation states, they have a range of oxidation states. Suppose I tell group 15 nitrogen. It has 5 electrons in its outermost shell. So if it has to complete its octet, it can attract 3 electrons. So if it can attract 3 electrons, it can have -3 charge. It can lose even 5 electrons. If it can lose 5 electrons, then obviously it can have +5 charge onto it. So we say that it has a range of oxidation state from -3 to +5. Any compound that nitrogen will be forming, it will be having oxidation state ranging from -3 to +5. But same thing if you would like to apply exactly onto alkali metals. They have 1 electron in the outermost shell. Suppose it has to complete its octet. How many electrons it will be needing? It will be needing 7 electrons. So leaving 1 electron is very easy for it. Readily it forms. So generally changing the oxidation state for alkali metals, and that too for hydrogen, very difficult, probably less known. Yeah, but yes, you're right. The oxidation state can be changed. I'm happy that you pointed it out. Very good. We'll talk about oxidation state. Very good. Okay, if I ask you one thing. In Earth's atmosphere or in Earth's crust, we find that there are 118 elements. Where have they come? Where have they come from? How these elements have come into the Earth's crust, or you can say, and we have different mines, like we have copper mines, we have iron mines. How these elements have come onto Earth's crust? Has anybody thought over it? Has anybody thought over it? How these elements have come onto it, come onto the Earth's crust? I'll tell you interesting fact about it. You know, Earth is Earth is a part of it has come out of sun only. Earth has been Earth is a part of sun, and when it cooled down, then it took the shape of Earth. I'm being too simplistic. In sun, there are various fusion reactions that are taking place. Let us understand. We have 3 hydrogen isotopes. Originally, hydrogen is the fuel. It is basically hydrogen which is burning inside sun. Let us try to understand. We have 1H1, right? And then let us have 1H3, right? 1H1, 1H3. Okay, 1H1, 1H3. Suppose these 2 isotopes combine, you will get what? 2He4. Suppose 1H1 combines with 1H2, it is deuterium, 1H3 is tritium, we get 2He3. Getting the point? We can have other combinations also, not many, but we can have some combination. But here you notice, we originally had hydrogen, we got helium just by the fusion process. So first it was hydrogen alone, with hydrogen, deuterium and tritium, about the isotopes that we are talking. Later, after the fusion process, we had helium and different isotopes of helium. Now we had 6 different elements, hydrogen and helium present. The combination of hydrogen, helium started in different manner. And this way we reached to different kind of elements. It was just the fusion process which gave rise to different kind of elements in sun, which later on got dissociated from sun and then cooled down, and we had different kind of elements which were into the manufacturing process for last several thousand years. And we have plenty of things. As the atomic number goes higher, the quantity of that element gets lowered. You will study it in principles of extraction of elements. As you go higher in atomic number, the quantity of that substance is getting less. You can understand. It is very easy to understand. Anyway, we have 3 isotopes of hydrogen. This hydrogen, deuterium, and tritium, and we write it like this. We will write 1H1 if we write this, we call as protium. 1H2 if we write, it is deuterium. Here 1 and 2, this 1 and 2 is telling about atomic number and mass number. Atomic number and mass number. Atomic number means number of proton. Mass number means number of proton plus number of neutron, both the things, right? So if we say tritium, tritium has one proton and two neutrons. Deuterium has one proton, one neutron. Protium, one proton only, no neutron, right? These isotopes differ from one another in respect of presence of neutrons, as I told you. Ordinary hydrogen has no neutrons, deuterium has one, and tritium has two neutrons in the nucleus. Okay, the predominant form is protium. Protium is plentifully available. Terrestrial hydrogen contains 0.0156% of deuterium, mostly in the form of HD. HD, hydrogen and deuterium that is combined, and then we have HD form. The tritium concentration is about 1 atom per 1018 atoms of protium, very less in quantity. And out of the three, protium, deuterium, and tritium, only tritium is radioactive and it emits low energy beta particles. And T half is 12.33 years. I don't know whether you know about half-life period and all, but I'll not elaborate it right now. We'll elaborate afterwards. Okay, let us come to how do we prepare hydrogen. We have variety of methods of preparation of hydrogen. We prepare hydrogen, very common laboratory method of preparation of hydrogen, and it includes reaction of granulated zinc with dilute HCl. Granulated zinc with a dilute HCl. I would like to mention here a couple of more things. We can use, we can use only dilute HCl and dilute H2SO4 while preparing hydrogen. No concentrated HCl, no concentrated H2SO4, no concentrated HNO3. All these three have their own problems. With H2SO4, it happens, it produces SO2. So along with hydrogen, sulfur dioxide is also being produced. It's a poisonous gas. With concentrated HCl, again, some kind of fuming takes place. And, the equipments are also destroyed. And there are various other things, other complications that also arise. With HNO3, different kind of coating also takes place. So in any case, we take dilute HCl and dilute H2SO4. You can use Zn plus H2SO4 dilute also to get ZnSO4 plus H2 hydrogen. This hydrogen that is come up, initially it is H, that is nascent hydrogen, combines to give H2, that is this. Here, look here, we are taking dilute hydrochloric acid. This is a flask. We can take wolf bottle also. And then here there is water. And one important thing that we need to mention here, there is a downward displacement of water. Downward displacement of water through which hydrogen is collected. If you will establish this, and you might be noticing there are some bubbles. These are hydrogen gas bubbles. Hydrogen gas bubble, gradually it comes up and gradually hydrogen is being filled in this flask and the level of water that keeps on coming down. So this way we prepare hydrogen, and this is the laboratory method of preparation of hydrogen gas. Now we have commercial production of hydrogen. Hydrogen is produced commercially. I would like to mention here a couple of things. The era in which you are living, you might be finding a lot of, lot of vehicles that are here. I'll tell you the timing of the daily lecture. For chemistry, you will come across. You'll have to. We will talk about the daily lecture. In general, we are having chemistry class on Monday, Wednesday, and Saturday. Monday, Wednesday, Saturday, and then will be the same here, 7 o'clock, 7 to 8 p.m. We will be having the class, right? Okay. We have electrolysis, commercial production of, what I was saying, we are having a lot of vehicles here, and the fuel that we are using, either it is CNG or it is petrol, within 5 years, all these things are going to stop. Within 5 years, all these things are going to stop. Hydrogen as a fuel is coming up very profusely, and your country is going to be pioneer on it. We'll wait and see. Wait and see. By the time you will have to purchase a vehicle, probably you will be purchasing a vehicle which is using hydrogen fuel, very clean fuel, no pollution. So hydrogen is important that way. So in commercial production of hydrogen, what we do electrolysis of water. The electrolysis of water is done in this manner. Here we have written the reaction also. Electrolysis of acidified water using platinum electrodes give hydrogen. We are putting two electrodes, pass electricity onto it, we get hydrogen. We'll get hydrogen as per these reactions. You can see to it. Hydrogen will be liberated onto cathode. Hydrogen will be liberated at cathode. Here we have anode reaction, we have cathode reaction. High purity dihydrogen is obtained by electrolyzing warm aqueous barium hydroxide solution between nickel electrodes. Sometimes it is asked how very pure hydrogen is produced. This is one such method. Barium hydroxide solution, when it is electrolyzed, we get 99.955% pure hydrogen, and this is called as high purity hydrogen. There are other methods also. If magnesium is also made to react with H2SO4, we also get very pure hydrogen. We have UNO method also. There again, we are using very pure hydrogen. It is obtained as a byproduct in the manufacture of sodium hydroxide and chlorine by the electrolysis of brine solution. Do you know what is brine solution? Brine solution means you dissolve sodium chloride in water. पानी में नमक मिलाने से. You're using sodium chloride in water, it's called brine solution. When brine solution is electrolyzed, these are the reactions that are taking place. In anode, we are getting chlorine gas. At cathode, we are getting hydrogen. In the container, we are left with sodium and OH minus. We are getting NaOH. So that's why it is said it is obtained as a byproduct in the manufacture of sodium hydroxide and chlorine by the electrolysis of brine solution. So this is the reaction. We do it for commercial production of hydrogen, right? This is an alternative method of electrolysis. It is by and large, it has already been told how we are using it. For this we use 15 to 20% acid or alkali. Alkali, water soluble base, NaOH or KOH, anything that we can use. This process is suitable for places where cheap electric supply is available. In India, it is plentifully available, cheap electric supply. You are getting electricity very cheap. Since water is a bad conductor of electricity, it is made conducting by the addition of small quantity of sulfuric acid or sodium hydroxide. So we have this reaction like this, H2SO4, when it is dissolved in water, we get hydrogen ion as well as sulfate. This does not get involved in the electrode reaction, the ion which gets oxidized at the anode in preference to OH minus. So we have reactions like at cathode, we are having hydrogen getting liberated. This H plus that we are having from H2SO4, it gets combined, takes electron, and then H2 is produced. And at anode, we are getting O2, oxygen we are getting. So the net reaction will be like this. Hydrogen and oxygen. If we are taking any acid or alkali and put it into water, electrolyze it, and when we are electrolyzing it, we are getting hydrogen and oxygen. Very simply, we can get it, right? So thinking that we are running short of oxygen, there is no shortage of oxygen, there is no shortage of hydrogen also. Yeah, let us come to another method of reactions of steam on hydrocarbon. And before I come to reaction of steam onto hydrocarbon, I would like once again to a couple of things which are of great importance, and I cannot choose to ignore that, and I need to make you aware of the classes of Altedemy. These are the courses that we have. We have 90 plus classes. We have a very convenient educational platform. Very convenient educational platform in the sense easy to join, easy to understand, easy to get access to a lot of things. We have NEET experts who are talking about different syllabus or syllabus that is prescribed for your NEET. And there is very important thing which we have mentioned here is a flipped classroom method, about which I'll tell very shortly what are those flipped classroom method. We have doubt solving practice. These are some of the things we are trying to improvise ourselves. We are trying to customize ourselves in a fashion so that we can suit to your need very properly, very judiciously, without wasting much of your time. As I told about this flipped classroom, these are the things that you should understand. How our classes look like. Plenty of theory that you will be getting. As my friend was asking, how can we get these study material? Yes, we will be getting all those things. We'll be getting whatever we are teaching, whatever PPTs we are having. It is all for you. We get variety of study material. Apart from the PPTs, we have study materials too. Very relevant study material, carefully written, carefully typed, and it is carefully made to be available to you. We conduct a lot of webinars also to make you aware of the latest update things, latest update. You need to attend those webinars invariably because it may be academic. At times, besides having academic webinar, we have a lot of such information, how to fill up your form for NEET examination, how to do a lot of other things which are of common information, common knowledge, and often students are missing. What are the other medical examination that are possible in your country? Which are the other medical colleges, India and abroad? A lot of information you'll be getting through your webinar, and you need it. You need it desperately. We strongly believe in homework. Whatever we are teaching, that is fine. Whatever study materials we are giving you, fine. Whatever tools that we are using, we are fine. Unless and until you do the homework, you do the self-study, nothing is going to happen. So remember, besides whatever classes that you are attending, you have to do plenty of homework. And homework means what? You have to do very smart work. We'll make you understand how to do smart work. Like it is not essentially required that you should be studying 12 to 13 hours a day and you should be cramming like you have to do smart work. Like instead of solving 200 questions, 200 multiple choice question in a day, I think if you solve 20 to 25 selected questions from a particular chapter, your job is over. So it is better to do 20 those selected questions instead of solving 200 different questions. Though if you practice more questions, your perfection comes more. Whatever homework you are doing, we have a method to cross-check also. Our teachers and other things, other faculty member will be taking. And the most important thing, we have different plans and different programs suiting to, keeping in view your pocket. Different financial situations can occur. You can have a variety of situations. So we have kept these three categories of, programs where we have a light program, we have a smart program, we have a proficient program, different kind of programs we have. What is the difference that you should note? If you are joining a light program, you will be having an interactive live classes, you have structured courses and PDF, you will have live test, you will have physical notes. This you will be having. We have a lot of other things also. Our most popular program is our smart program. Most popular program. Most of the students are subscribing to our smart program, and economically also, financially also, it is a good program. You should talk about. You should try. In case you plan to go with us, you should definitely choose a smart program, because in a smart program, in addition to whatever benefits that you have to the light program, we have one-to-one mentorship. You need it. You need it at times. Doctors are the lot which are the most depressed at times. You need encouragement. You need mentorship. You need to know what to study, how to study, when to study. These are a lot of things. These mentorship will be of great importance. It will play. It has started playing great roles, right? There are live doubt solving classes. live doubt solving. Come up with your doubt, we'll be solving all those things. Okay, we conduct mock tests regularly. You will have plenty of mock tests, and then we have proficient program. We have additional special courses that is added. But I mean, if you ask me, I think your smart program will be the best program suited for your need. You can go for a smart program like that. Okay. So I think that is that is uh, that is all about Altedemy. We can again come back to our these small things where we are did. Uh, we have variety of things again. We have plenty of things mentioned in our lectures. Like we had left the things here. Yeah, reaction of steam on hydrocarbon. It is another method of preparation of hydrogen. You can just have a look. We have again water gas shift reaction. This is again a different kind of reaction through which commercially we produce hydrogen. Here, important thing is that you should know the name of one. Look at CO plus H2, carbon monoxide plus hydrogen that we are saying, taking. CO plus H2. It is also called as water gas. Since it is used for synthesis of methanol and a number of other hydrocarbons, it is also known as syngas. So water gas and syngas are the same thing, one and the same thing. And the process of producing syngas from coal gas is called coal gasification. Again, a term you need to be familiar with. We have water gas shift reaction. This reaction is a coal gasification reaction. This reaction is a coal gasification reaction, and this is the water gas shift reaction. Right? We have chemical properties of hydrogen. Hydrogen, as I told you, H2 is very difficult to react. But then, under different situations, like hydrogen reacts with halogens to give HX, as we have mentioned. H2 reacts with halogens to give HX. These portions that we have already seen, right? Okay. H2 reacts with oxygen to give H2O. This is again delta H. It is an exothermic process. Delta H negative is an exothermic process. Hydrogen reacts with nitrogen at about 450 to 500 degrees centigrade and under high pressure, 200 to 900 atmospheric pressure, in the presence of a catalyst to give ammonia. You might be familiar or aware of this Haber's process, that the reaction of H2 plus N2 we have mentioned here. H2 plus N2 is 673 Kelvin and it forms ammonia. Again, it is an exothermic process. Heat is liberated in this process. So among chemical properties of dihydrogen, formation of ammonia is very important. The rest of the things are also very, equally important, like formation of any kind of acid. When we make it to react with fluorine, chlorine, bromine, iodine, it is also equally important. Another important thing you should bear in mind, reaction with fluorine occurs even in dark, but with iodine it requires a catalyst. It requires a catalyst to react. Okay. This is another important section, which is called as ortho and para hydrogen. And bear in mind, this ortho and para hydrogen has got nothing to do with, as you study in ortho and like we say ortho nitrophenol or para nitrophenol, it has got nothing to do with that benzene structure. What is ortho and para hydrogen? Look, when two hydrogen atoms will be combining, like we have one hydrogen, two hydrogen will be combining, then obviously the spin of electron has to be opposite in all the cases. If the electrons will be in opposite, the spin of electron will be in opposite direction, there will be proper combination or fruitful combination. But what about the nucleus? In nucleus we have proton, and this is also rotating. So ortho and para hydrogen is all about that. If the spin of nucleus is both the nucleus are spinning in one direction, it makes an ortho hydrogen in one direction. As you can see in this diagram, Both these are moving in one direction. We call this ortho hydrogen. And if the nuclear spin is in opposite direction, this is called as para hydrogen. It is one very important concept. Normally, at room temperature, ordinary hydrogen consists of about 75% ortho and 25% para. This happens at room temperature. We have 75% ortho and 25% para hydrogen. As we lower the temperature, the content or the percentage of ortho increases. The percentage of para increases. Like there is an example at 25 Kelvin, we have 1% only ortho form, 99% para. As the temperature is lowered, para percentage increases. But there is a tag also attached with it. Despite having this large percentage of para and less percentage of ortho, yet till date we are not in a position to isolate 100% pure ortho hydrogen. We have again different form of hydrogen about which we have already discussed. We have nascent hydrogen, we have atomic hydrogen, and we have occluded hydrogen. This occluded hydrogen is basically what you might have come across in organic chemistry, some reduction procedure, hydrogenation, like you use hydrogen in the presence of nickel, platinum, or palladium. These are the things that you use for hydrogenation. Like if you are hydrogenating CH2, double bond CH2, and hydrogen is being used, then here you use nickel, platinum, or palladium. You use. Now, the special role for nickel, platinum, or palladium, it will be for occluded hydrogen. This again is a very reactive category of hydrogen that you come across or that we come across. It is again a reactive type of hydrogen. Out of this nascent atomic and occluded hydrogen, atomic hydrogen is the most reactive, and it can be obtained by molecular hydrogen on a hot filament of tungsten or platinum. Nascent hydrogen, it can be produced by any of the methods that we have mentioned above, and occluded hydrogen generally with any of these metals, nickel, platinum, palladium. You should know also know about this particular thing. There is a substance, we call this as colloidal palladium. Colloidal palladium. Colloidal palladium absorbs 1800 times of its volume to hydrogen. That means if we have 1 meter cube of colloidal palladium, then we can have 1800 cubic meter of hydrogen adsorbed onto it. Colloidal palladium adsorbs very readily, very effectively, and often colloidal palladium is used for adsorption. There are variety of uses of hydrogen. This you can see in this PPT also. It is used as a reducing agent. It is used profusely in the synthesis of ammonia. It is used in the hydrogenation of vegetable oil. The hydrogenation of vegetable oil, there you use atomic hydrogen. Hydrogenation of vegetable oil. This is also used as oxy and atomic torch. Hydrogen economy is a different thing. Hydrogen economy is will be discussed later on. And here all those uses that you are seeing, these 5 uses in a nutshell. The detail of it is written out here. Dihydrogen is used in the manufacture of vanaspati fat by the hydrogenation of poly. This kind of things. Let us come to hydride. We will try to finish it here with this hydride. Hydrogen forms various kinds of hydrides, and when we are saying it is hydride, hydride means what? Hydride means it is H minus, always H minus. It is hydride. H minus is hydride, and various kind of hydrides that we are having. We have, you can just see here, we have ionic or saline hydrides, and it is formed basically by group 1 and group 2 elements. Here you can see here group 1 and group 2 elements. These are what? Ionic or saline hydrides. lithium hydride, beryllium hydride, sodium hydride, potassium hydride. Such kind of hydrides are called as ionic or saline hydrides. Right? These hydrides, what do? They conduct electricity in aqueous solution and in molten state. They evolve H2 at anode when electrolyzed. This stability decreases with increase in size of metal. There are a lot of other things. Now we have covalent hydrides. Covalent hydrides obtained by p block elements. Here you can see these are covalent hydrides. Covalent hydrides. Covalent hydrides obtained by p block elements. All those p block elements BH3, CH4, NH3, you can see these are covalent hydrides that are formed. We have interstitial hydrides. Interstitial hydrides are generally formed by d block element, also called as interstitial solid. I will tell you about interstitial hydrides. They basically form non-stoichiometric compounds. Non-stoichiometric compound. Non-stoichiometric compound. Again, it is a matter to be elaborated. What is non-stoichiometric compound? What is a stoichiometry? Suppose we say sodium chloride. So in the crystal structure of sodium chloride, there will be one sodium, one chlorine. So it is maintaining the stoichiometry. So we say this is stoichiometric compound. Suppose we write something different in the sense, let us say we write Ni 0.98 O 1.00. Now this is a non-stoichiometric compound. Normally Ni and O, it should form a compound like NiO. It has got +2 valency, -2, so it can compound, and nickel oxide it will be formed. But here, if it is forming a non-stoichiometric compound, this usual stoichiometry is not maintained. So such kind of hydride is also given by hydrogen. And apart from these interstitial hydride, we have polymeric hydrides also. You might have heard about lithium aluminum hydride, LiLH4. It is a different type of hydride. It is called as polymeric hydride, NaBH4. These are some other hydrides which are polymeric in nature, right? I think we have covered almost all those things. I'll once again I would like to remind you about Altedemy, and we are coming up with with plenty of things for your benefit, and I'll request you to join. With this much, I just bring into this session of our discussion. We will be coming up with second and third session also on hydrogen, probably with in a much improved manner and in a much better manner, because well, familiarity is also a kind of thing which is very important. But until then, keep on preparing for NEET. Try hard. The only way to success is working hard. Keep on solving a lot of questions, and we love you for working hard. Thank you very much. We can choose to leave. Thank you.